Welcome to The Explainer. Today, we're going to trace the incredible path of digital security from a tiny lockdown vault inside your phone's processor all the way up to the massive cloud services that connect our entire world.
Have you ever really thought about that? I mean, when you unlock your phone with your fingerprint, that data, your unique biometric print, has to be completely walled off from every other app, every potential piece of malware. So how does it do it? Well, the answer lies in a hidden, high-security vault that's built directly into your device's processor.
To really understand this vault, we have to rewind the clock a bit, back to the early 2000s, when the biggest name in mobile phones had a security problem they desperately needed to solve.
Back then, Nokia was king. They knew the security that SIM cards offered was valuable, but they wanted something more, something permanent, something that was physically part of the device itself. They needed a secure environment that couldn't just be popped out, one that would let them offer secure services no matter what carrier you used.
So they took this challenge to the chip designer ARM, and that conversation sparked the creation of a whole new kind of hardware-enforced secure environment. This idea eventually got formalized by a group called OMTP and was later standardized by Global Platform, creating the common foundation for the device security that pretty much all of us rely on today.
Okay, so let's crack open this digital vault and see what's really going on inside. This concept is known as the Trusted Execution Environment, or TEE for short.
Seriously, the best way to picture it is as a bank vault built right into the main processor. Your normal operating system, Android or iOS, it knows the vault is there. It can even knock on the door and pass messages, but it has absolutely no way to get inside and see what's happening.
Now, I know this slide looks a little technical, but the single most important thing to see here is that big dividing line right down the middle. On the left, you've got the normal world, your apps, your user interface. We call that the Rich Execution Environment, or REE. And on the right, totally walled off, is that secure vault we've been talking about, the Trusted Execution Environment, or TEE. They are running on the exact same chip, but they are worlds apart. So here's the crucial point. All your everyday apps, social media, games, you name it, they all live in the RE. It's an open world which is great for innovation, but it's also exposed to threats. The TE, on the other hand, runs its own tiny, separate, super secure operating system, and it only allows specially vetted, signed, trusted applications to run inside, completely firewalled off from everything else.
So what makes this firewall so strong? Well, it's not just one wall. It's a fortress with multiple layers of defense. The hardware itself enforces that separation. And get this, even inside the TEE, the trusted apps are isolated from each other. Any data it stores is encrypted. It can even take over the screen and keyboard when you enter a PIN, making sure the main OS can't snoop on what you're typing.
Okay, theory is great, but let's see how this tech actually shows up in features you use every single day.
Remember our fingerprint question from the beginning? Here's the magic. When you scan your finger, that data goes straight into a trusted app inside the TEE. The TEE does the comparison to the template it has stored and then just tells the main OS a simple yes or no. Your actual fingerprint data, it never, ever leaves that secure vault.
It's the exact same principle for mobile payments. Your credit card details are locked away inside the TE. When you tap to pay, the TE handles the secure transaction and authorization, protecting your financial info from any malware that might be lurking on your phone.
And it's not just about payments or biometrics. Ever wonder how you can stream a 4K movie without it being pirated? The TEE is a huge part of that. It makes sure that once that movie is decrypted on your phone, it goes directly to the screen to be viewed, but it can't be copied or screen captured by any other software.
Okay, so the TEE is fantastic at securing the device itself. But our devices are constantly talking to the outside world, right? How do we securely connect these little digital vaults to the huge ecosystem of cloud services? How does that protected data get from your phone to a server without being exposed along the way?
Well, the answer is something called an API gateway. Think of it as the single, secure front door for all the services running on a network. For any complex system, from your smart home gadgets to massive corporate networks, this is absolutely critical. All requests have to go through the gateway first, no exceptions.
The process is actually pretty simple but incredibly powerful. A request comes in from the outside world. The gateway grabs it, looks at the address to see where it's supposed to go, and then forwards it to the correct internal service, which is safely hidden away from the public internet. It simplifies everything and puts a choke point on all access.
Let's use a mail analogy. This request here is like a letter arriving at a big office building's mailroom.
The gateway is the mailroom clerk. It looks at the address on the envelope. In this case, it's for the /vst/department, and it knows exactly where to route it. To the internal video storage toolkit service, an office that you can't just walk into from the street.
Okay, now imagine scaling this up. A big company might have thousands of these API connections. Managing the security for all of them becomes a monumental, almost impossible challenge.
And this is where modern security platforms are a total game changer. They go way beyond simple firewalls. Instead, they used AI to watch all the API traffic over days, weeks, even months. They learn what's normal so they can spot those really sophisticated, slow-burn attacks that are designed to fly under the radar.
This all leads us to the next massive evolution in security, an idea called SASE. The big idea is this. Instead of a company juggling a dozen different security products for firewalls, network access, and data protection, SASE bundles all of it into a single smart service that's delivered from the cloud.
So, what's that actually mean in practice? It means everything is managed in one place. You have one intelligent cloud platform handling all your security. And the key benefit here is simplicity, and a powerful idea called zero trust, which basically means no one is trusted by default. This lets employees securely access any application from anywhere in the world without the company having to manage a messy patchwork of old security products.
So let's just pause and think about where we started. We began with a tiny, secure vault on a single chip. And from that one concept, we've built out this incredible global ecosystem of interconnected, secure services.
The fundamental principles we talked about, isolation and trust, that started way back with the TE, have now scaled up to secure our entire digital economy. From the car you drive, to your online banking, to the smart devices in your home, these layers of trust are working behind the scenes all the time.
And this brings us to a final, really thought-provoking question. As all these systems become more and more integrated, we're constantly navigating this balance between the security that manufacturers provide and our own control over our devices and our data. How we manage that balance is going to continue to shape the future of all of our digital lives.